Transient voltage surge suppression, or TVSS, is a critical aspect of electrical system protection. It focuses on mitigating the effects of transient overvoltages, which are short-duration voltage spikes or surges that can damage sensitive electronic equipment. These surges can originate from various sources, including lightning strikes, utility grid switching, and the operation of heavy electrical equipment within a facility. Understanding the principles of TVSS is essential for ensuring the reliability and longevity of electrical and electronic systems. TVSS devices are designed to limit the magnitude of transient voltages to a safe level, preventing damage to connected equipment. They achieve this by diverting the surge current away from the protected load. Several technologies are employed in TVSS devices, each with its own characteristics and application suitability. A common type of TVSS device uses metal oxide varistors, or MOVs. MOV are voltage-dependent resistors that exhibit a high resistance at normal operating voltages but drastically decrease their resistance when a transient overvoltage occurs. This allows the surge current to be shunted to ground, limiting the voltage across the protected equipment. Another type of TVSS device utilizes silicon avalanche diodes, or SADs. SAD are semiconductor devices that exhibit a sharp breakdown voltage. When the voltage across the diode exceeds its breakdown voltage, it conducts heavily, clamping the voltage to a safe level. SAD are generally faster and more precise than MOV but have a low surge current handling capability. Gas discharge tubes, or GDTs, are another technology used in TVSS devices. GDT consists of a sealed glass or ceramic tube filled with an inert gas. When a high voltage is applied across the tube, the gas ionizes, creating a low impedance path for the surge current to flow to ground. GDT are capable of handling very high surge currents but are relatively slow to respond compared to MOV and SAD. The selection of the appropriate TVSS device depends on several factors, including the magnitude and duration of the expected surges, the sensitivity of the protected equipment, and the desired level of protection. TVSS devices are typically installed in a layer approach, with higher energy devices located at the service entrance and lower energy devices located closer to sensitive equipment. This layered approach provides comprehensive protection against a wide range of surge events. TVSS devices are characterized by several key parameters, including their voltage protection rating, surge current capacity, and response time. The voltage protection rating indicates the maximum voltage that the TVSS device will allow to pass through to the protected equipment. The surge current capacity indicates the maximum surge current that the TVSS device can safely handle. The response time indicates how quickly the TVSS device can react to a surge event. When selecting a TVSS device, it is important to consider these parameters and ensure that they are appropriate for the intended application. Proper installation of TVSS devices is also crucial for their effective operation. TVSS devices should be installed as close as possible to the protected equipment and should be properly grounded. The grounding conductor should be as short and straight as possible to minimize impedance. It is also important to ensure that the TVSS device is properly sized for the electrical system. An undersized TVSS device may not be able to handle the expected surge currents, while an oversized TVSS device may not provide adequate protection for sensitive equipment. TVSS devices are available in a variety of configurations, including plug-in modules, panel-mounted units, and hardwired devices. Plug-in modules are typically used for protecting individual electronic devices, while panel-mounted units are used for protecting entire electrical panels. Hardwired devices are used for protecting critical equipment and systems. In addition to protecting against external surges, TVSS devices can also protect against internal surges caused by switching events within the facility. These internal surges can be just as damaging as external surges and should be taken into consideration when designing a TVSS system. Regular inspection and testing of TVSS devices is essential to ensure their continued effectiveness. TVSS devices can degrade over time due to repeated exposure to surge events. It is important to periodically test the TVSS devices to ensure that they are still functioning properly. Some TVSS devices have built-in indicators that provide a visual indication of their status. If a TVSS device fails, it should be replaced immediately. In summary, transient voltage surge suppression is a critical aspect of electrical system protection. TVSS devices protect against transient overvoltages that can damage sensitive electronic equipment. Several technologies are employed in TVSS devices, including metal oxide varistors, silicon avalanche diodes, and gas discharge tubes. The selection of the appropriate TVSS device depends on several factors, including the magnitude and duration of the expected surges, the sensitivity of the protected equipment, and the desired level of protection. Proper installation and regular inspection of TVSS devices are essential for their effective operation. Understanding the electrical principles related to surge protection is paramount to understanding the effectiveness and deployment of TVSS systems. Electrical surges are, at their core, rapid increases in voltage significantly above the normal operating voltage. These surges can be caused by various factors, with lightning strikes being the most dramatic and well-known. However, more common causes include switching events by the utility company, inductive load switching within a facility, and even electrostatic discharge. When a surge occurs, the excess voltage can stress or even destroy electronic components, leading to equipment failure, data loss, and potential safety hazards. The fundamental electrical concept at play is Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. When a surge occurs, the voltage increases dramatically. If the resistance of the circuit remains constant, the current will also increase proportionally. This increased current can overheat conductors and damage components. TVSS devices work by providing a low impedance path for the surge current to flow to ground, thereby limiting the voltage across the protected equipment. This is often achieved through the use of components like MOV, which exhibit a high resistance at normal operating voltages but a very low resistance when a surge occurs. The MOV effectively clamps the voltage to a safe level, diverting the excess current away from the sensitive equipment. Grounding plays a crucial role in surge protection. A properly grounded electrical system provides a low impedance path for the surge current to flow to earth, minimizing the voltage rise within the system. The grounding conductor should be as short and straight as possible to minimize its impedance. A high impedance grounding conductor can impede the flow of surge current, reducing the effectiveness of the TVSS device. The National Electrical Code, or NEC, provides guidelines for proper grounding and bonding of electrical systems. Adhering to these guidelines is essential for ensuring effective surge protection. The NEC also addresses the selection and installation of surge protective devices, or SPDs, which are devices designed to protect against transient overvoltages. Article 280 of the NEC covers SPD and provides requirements for their listing, marking, and application. Another important electrical concept is inductance. Inductance is the property of an electrical circuit that opposes changes in current. When a surge occurs, the rapid change in current can induce voltages in nearby conductors. These induced voltages can also damage sensitive equipment. TVSS devices can help to mitigate the effects of induced voltages by clamping the voltage at the source of the surge. Surge protection is not a one-size-fits-all solution. The level of protection required depends on several factors, including the location of the facility, the type of equipment being protected, and the criticality of the equipment. Facilities located in areas with high lightning activity require a higher level of surge protection than facilities located in areas with low lightning activity. Sensitive electronic equipment, such as computers and medical devices, require a higher level of surge protection than less sensitive equipment, such as lighting fixtures. Critical equipment, such as life support systems and data centers, require the highest level of surge protection. A comprehensive surge protection system typically involves multiple layers of protection. The first layer of protection is typically located at the service entrance, where the electrical service enters the building. This layer of protection is designed to protect against large surges caused by lightning strikes and utility grid switching. The second layer of protection is typically located at the electrical panel boards, which distribute power throughout the building. This layer of protection is designed to protect against smaller surges caused by switching events within the facility. The third layer of protection is typically located at the point of use, near sensitive electronic equipment. This layer of protection is designed to protect against very small surges that can still damage sensitive equipment. Selecting the right type of TVSS device for each layer of protection is crucial for ensuring effective surge protection. Factors to consider include the voltage protection rating, the surge current capacity, and the response time of the TVSS device. The voltage protection rating indicates the maximum voltage that the TVSS device will allow to pass through to the protected equipment. The surge current capacity indicates the maximum surge current that the TVSS device can safely handle. The response time indicates how quickly the TVSS device can react to a surge event. In addition to selecting the right type of TVSS device, it is also important to properly install and maintain the TVSS devices. TVSS devices should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. TVSS devices should be inspected regularly for signs of damage or degradation. TVSS devices should be replaced when they reach their end of life. Understanding the electrical principles behind surge protection is essential for designing and implementing effective TVSS systems. By considering the factors discussed above, you can ensure that your electrical systems are protected against the damaging effects of voltage surges. The effectiveness of a TVSS system depends not only on the quality of the devices used but also on the overall design and implementation of the grounding and bonding system. A well-designed grounding system provides a low impedance path for surge currents to flow to ground, minimizing the voltage rise within the system and protecting sensitive equipment. The NEC provides detailed requirements for grounding and bonding in Article 250. These requirements are based on the principles of electrical safety and are essential for ensuring the effective operation of TVSS systems. One of the key concepts in grounding is the establishment of a low-impedance ground reference. This is typically achieved by connecting the electrical system to a grounding electrode system, which consists of one or more grounding electrodes that are buried in the earth. The grounding electrode system provides a stable reference point for the electrical system and helps to dissipate surge currents into the earth. The grounding electrode system should be installed in accordance with the NEC and should be tested periodically to ensure that it is functioning properly. Another important aspect of grounding is the bonding of all metallic components within the electrical system. Bonding ensures that all metallic components are at the same electrical potential, minimizing the risk of electrical shock and reducing the impedance of the grounding path. The NEC requires that all metallic components, including metal conduits, metal enclosures, and metal equipment frames, be bonded together. Bonding conductors should be sized in accordance with the NEC and should be installed in a manner that minimizes impedance. In addition to grounding and bonding, surge protection devices should be properly coordinated to ensure that they work together effectively. Coordination involves selecting surge protection devices with appropriate voltage protection ratings and surge current capacities. The surge protection devices should be installed in a manner that allows them to share the surge current load. Proper coordination can improve the overall performance of the TVSS system and extend the life of the surge protection devices. Regular inspection and maintenance of the grounding and bonding system are essential for ensuring its continued effectiveness. Grounding and bonding connections can corrode over time, which can increase their impedance and reduce their effectiveness. The grounding electrode system should be inspected periodically for signs of corrosion and should be replaced if necessary. Bonding connections should be tightened regularly to ensure that they are making good electrical contact. By following these guidelines, you can ensure that your grounding and bonding system is providing effective surge protection for your electrical systems. Remember that surge protection is an ongoing process. As technology advances and electrical systems become more complex, it is important to stay informed about the latest surge protection techniques and technologies. By continuously improving your surge protection system, you can protect your valuable equipment and ensure the safety of your facility. The application of TVSS in different settings also varies depending on the sensitivity of the equipment and the environment it's in. For example, in residential settings, surge protection is often implemented at the service entrance to protect the entire home from external surges. Additional surge protection may be installed at individual outlets to protect sensitive electronics like computers and televisions. In commercial and industrial settings, surge protection is typically implemented in a layered approach. Higher energy surge protection devices are installed at the service entrance to protect against large surges, while lower energy surge protection devices are installed at distribution panels and individual equipment to protect against smaller surges. In critical facilities such as hospitals and data centers, surge protection is even more important. These facilities often have redundant surge protection systems and backup power supplies to ensure that critical equipment remains operational during a surge event. The cost of surge protection is a small price to pay compared to the cost of replacing damaged equipment and the potential downtime associated with a surge event. A properly designed and installed TVSS system can provide years of reliable protection and save significant money in the long run. When selecting a TVSS device, it is important to consider the specific needs of your application. Factors to consider include the voltage protection rating, the surge current capacity, the response time, and the type of surge protection technology used. It is also important to choose a TVSS device that is listed by a recognized testing laboratory such as Underwriters Laboratories or A UL listing indicates that the TVSS device has been tested and meets certain safety standards. In addition to selecting the right TVSS device, it is also important to install it properly. TVSS devices should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. The grounding conductor should be as short and straight as possible to minimize impedance. The TVSS device should be located as close as possible to the equipment being protected. Regular inspection and maintenance of TVSS devices are essential for ensuring their continued effectiveness. TVSS devices can degrade over time due to repeated exposure to surge events. Some TVSS devices have built-in indicators that provide a visual indication of their status. If a TVSS device fails, it should be replaced immediately. Surge protection is an essential part of any electrical system. By understanding the principles of surge protection and selecting the right TVSS devices, you can protect your valuable equipment and ensure the safety of your facility. Furthermore, it is worth mentioning the advancements in TVSS technologies. Smart surge protection devices are now available that can monitor the performance of the electrical system and provide alerts when a surge event occurs. These devices can also provide data on the magnitude and duration of surge events, which can be used to improve the design of surge protection systems. Another trend in surge protection is the use of hybrid surge protection devices. These devices combine different surge protection technologies, such as MOV and SAD, to provide enhanced performance. Hybrid surge protection devices can offer a wider range of protection and a longer service life than traditional surge protection devices. As electrical systems become more complex and sensitive, the importance of surge protection will only continue to grow. By staying informed about the latest surge protection technologies and techniques, you can ensure that your electrical systems are protected against the damaging effects of voltage surges. Moreover, consider the role of preventative measures to reduce the likelihood of surges. Implementing proper wiring practices, such as avoiding long wire runs and using shielded cables, can minimize the impact of induced voltages from external sources. Regularly inspecting and maintaining electrical equipment can identify potential problems before they lead to surges. Educating personnel about the importance of proper grounding and surge protection can also help to prevent surge-related incidents. Finally, keep in mind that surge protection is not a one-time investment. It is an ongoing process that requires continuous monitoring, maintenance, and upgrades. By staying proactive and informed, you can ensure that your electrical systems are always protected against the threat of voltage surges. Considering the broader context, the resilience of electrical infrastructure is vital for societal functions. Disruptions caused by surges can lead to significant economic losses, inconvenience, and even safety hazards. Therefore, investing in comprehensive surge protection measures is not only a smart business decision but also a responsible approach to safeguarding communities and ensuring the reliable operation of essential services. As technologies continue to evolve, staying abreast of the latest advancements in surge protection is essential for maintaining a robust and resilient electrical infrastructure.